welcome everybody. I mean, this is for those of you who attend this session for the first time. We've had previously 8 more sessions. We've had one every month, and they've been the presenters have been always the NetApp on NetApp team. Today, and I send a newsletter every month, and in that newsletter you have the link where we've posted all the recordings of these sessions, the previous sessions, and also where you can get the presentations. Today we have Ed who's the senior manager for automation.
Thank you very much. So good morning, and I understand probably afternoon for most of the folks on the call. Thanks for joining. Again, just a little bit about myself. My name is Ed Wang. I'm the senior IT manager for our NetApp IT's automation and monitoring tools team. So in that role, basically what we focus on are 2 separate areas. One of them is about creating the automation capability for our cloud technologies, so provisioning, deprovisioning, and everything else in between. The other part of my job is to run the monitoring capabilities. So most of the monitoring tools are under my umbrella. How do we integrate it? How do we maximize the capabilities? Are all part of the charter of my team. I joined NetApp in 2011, so it's been about 8 years. I ran a team that provides the managed hosting support for external customers at a managed service provider. Okay, so we're going to start and kind of. I want to share with you guys just a little bit about our hybrid cloud evolution. So prior to 2015, we were really still focusing on standardizing our hardware, and also focusing more on the virtualization, right? So we're focused, like a lot of the companies, on the virtual to physical ratios, ESX and stuff like that, building standards and building out automation. Toward the end of that period, we started looking at how our NetApp customers, our business units, and how they were, turning toward, the providers such as AWS, and really kind of swiping that credit card, if you will, and creating their own environment. So as we were looking at that, we said to ourselves, this is going to potentially become a problem, because ultimately when something breaks, our customers are going to come to us and say, you guys need to help us fix it, and not knowing what was actually done to put that environment together is going to become a challenge for us as far as support goes. So at that time, we realized we really need to embark on our own cloud journey within IT, so that we can provide a service. So IT becomes a broker of cloud services for our customer. And that's when we started the private cloud deployment, along with our data fabric, self-service catalog, and ultimately what we got to was almost an AWS-like service or service front end, where our customers can actually go to a ServiceNow portal and click a few buttons, and they will either get a set of servers on-prem or in AWS, depending on their business needs. In the last year or two, so now we're kind of talking about our Cloud One journey over here. What we've kind of evolved is we looked at the infrastructure as a service, so that's great. We can provision servers, but what we really want to be able to do is 2 things, right? We want to be able to start creating some automation around CI/CD, and on top of that, we want to be able to start building an application stack that is container based. So in the last year or so, we started doing that, providing automation very similar to infrastructure as a service, but now we're talking about a containerized environment, provisioning entire application stack, We started with that journey with AWS again, and then we moved on to creating a private cloud using NetApp HCI. As we're kind of going down this journey, our latest, I would say, project, if you will, is to now say, hey, you know what? Now that we've built this thing, what we want to be able to do is really put some of our critical apps on there, right? In the past, for the cloud, we did a lot of the the applications that, if it goes down, it's not that it's not a big deal, but it's got less impact. But now what we really want to do is make sure that we have a robust enough environment to put some of our key applications on there. So in fact, that's the project that we're currently focusing on right now, as far as, ensure that environment is robust, and also making sure that we've got the operational support to back that up. So as we kind of move forward beyond 2019, some of the focus areas that we're going to be looking at is to start looking at the inter-process or the inter-container communication, leveraging service mesh, API gateways, and then also continue to mature our what we call the Cloud One infrastructure. So I just kind of mentioned the word Cloud One. So what is it? So it's basically the DevOps platform that we built that, in the last year or so. So that's this area over here. And what is Cloud One? Well, first of all, it's built by our Custom One team, which is really a virtual team at this point. So it includes, our infrastructure people, our application folks, and Customer One. The Customer One team is focused on taking our own NetApp products and be one of the first customers to start leveraging the technology that's developed by NetApp, right? So we're the early adopters of NetApp technology. Cloud One is also we're hoping to be the one-stop shop for all the services, infrastructure as a service, platform as a service. If somebody just wants a set of vanilla containers, right, to provide that container as a service capability, and then also building the automation that DevOps need to do that automated CI/CD pipeline. Deliver one offering for private cloud and public cloud. So when our customers, our business users need something, in the cloud, if you will, we're the one-stop shop. They come to us, and we'll be able to provision AWS, or we'll be able to provision something that's on-prem. Today, our focus on AWS, and in the near future, we're going to look at Google and Azure as well. And again, across the board, one consistent user experience, regardless of where the servers or the containers are lying, right? As far as the user is concerned, they're going to see the one single front end. Their developer experience is going to look the same, regardless of where their stuff is actually sitting. So I'm not going to go in too much detail as far as different pieces of this, but this is a slide that our team uses sometimes to kind of describe exactly what that application, what that process looks like when a developer says, hey, you know what, I want an environment built for us so that we can do our work, whether it be hosting the application or doing that development work. I'll start backwards really quick here in that, we have a concept of the host space, the workspace, and the data space. The host space is basically where our stage and production environment is going to sit, right? So anything, any quote unquote servers, if you will, that are meant to be production or staging area, they're going to be built as part of the host space. The data space is database as a service, something that we're currently developing. The workspace is actually where the developers will do their work, do their development work. So this will be their dev and test environment. And they develop in the workspace, and as the code matures, when it's ready for prime time, they go through the CI/CD process, actually promoting that into the host space, so that it's kind of a smooth transition, right? So that's kind of, I want to kind of share that definition over here as far as host space, data space, and workspace for you guys. Now, now going back to the start of this slide. So basically, as a developer, let's say I'm a developer, what would happen is I would say, hey, you know what, I think I need a space for me to work. I will go to ServiceNow front end, there's a portal there, and through the service catalog, I can actually just click a few buttons, and a couple of things will happen. ServiceNow will then send the request to CloudForm and Ansible Tower, and it will actually build out all the different components that you see over here, right? So it will create the, create the projects, it will create the containers necessary, you'll generate the membership using our internal tool Neat, all the different components as far as Artifactory and most importantly, the Azure DevOps, which provides our development tool, will all get integrated into that space. And then our developer will just get a notification saying your space is set up. And then they will be able to go into Azure DevOps and start doing that development. Along the way, we actually have also integration with our CMDB. So as things are getting created, it actually gets updated in our CMDB so we can keep track of the resources. Okay, so again, what we wanted to do is provide that consistent experience, and whether this is sitting in AWS or this is sitting on-prem, as far as the developer is concerned, it all looks the same. Okay. So that was Cloud One, and if you can see, Cloud One is really kind of depicted in this half of the picture, right? So again, we have AWS that's providing the compute. The containers are running, within Kubernetes. We have OpenShift as the platform that sits on. Trident, which is a module that NetApp actually provides for the NetApp storage. Really powerful module in that its sweet spot is to be able to provide that persistent volume for the environment. For the public cloud, we leverage Cloud Volume as well as NetApp Private Storage, for our storage capabilities. And then obviously we integrate with Azure DevOps, which provides that developer experience. In the private cloud, very similar. Kubernetes, should look very much the same. For the infrastructure piece, we use NetApp HCI, as I mentioned before, and then we have the NetApp AFF, the all fast flash. So the reason why I really want to show this slide is actually one of my favorite slides. Is it really kind of depicts how everything fits together, right? So not just the infrastructure and the infrastructure technology that is used to provide that environment for our developers, but it also provides some information about some other components I really do want to talk about. I'll start by saying this. If we look at this, right, in this slide over here, the creation of the host space, workspace, and data space, and once the developer is done with the environment, the decommissioning of those environments are really, if you think about it in the grand scheme of things, a very short period of time in the life of that environment. And what I mean by that is the provisioning, we've gotten it down to, and we tout this very proudly, to, hours, if not minutes, as far as the amount of time it takes to create the environment. In deprovisioning, very similarly, we can go from hour down to minutes to get rid of an environment when a developer is done with it. But what happens during the time when that environment actually exists as the developers are using it? Very few people really kind of talk about that, right? Everybody wants to talk about how great it is to create great automation and how fast they can provision and deprovision. But I would make the argument that the time in which it exists is almost just as important, if not more important. And that's where our other capabilities come in, right? To be able to manage the entire life cycle rather than just the provisioning and the deprovisioning. So there's a couple of areas that we want to focus on in this case. ServiceNow, again, we mentioned it before, it provides our CMDB as well as our service catalog, the front-end portal, if you will. Well, ServiceNow also help us keep track of our asset. It provides our change management capability, our problem management capability, and our incident management capability. it really is kind of the one-stop shop for our IT service management, right? Once the environment is built, we actually have a plethora of monitoring tools that we put in place. One of the things that we learned as we're kind of going through our monitoring journey was that any vendor that wants to tell us that, hey, you know what, I got the perfect monitoring tool that can do everything, usually doesn't turn out to be the case. I've gone through many conferences, walked many vendor floors, and talked to many vendors who claim that they have the monitoring tool that does everything. And usually what it boils down to is, when I ask the right questions, the answer often is, well, that's in the roadmap, or just flat out, we don't do that at all. So we learned relatively quickly that the magic bullet monitoring tool is not out there. So instead, what we did was we took the approach of two criteria. A, find the best of class for that particular capability, right? So go out and find the best application performance management tool. Go out and find the best data analytics tool. And then number two, really focus on answering the question of, is this tool inherently good at integrating with other pieces of the puzzle, right, or other tools? So when I go out and talk to a vendor about potential monitoring tool, one of the first questions I ask is, can I send things to it, and can it send things to other monitoring tools if I want to kind of build that holistic picture? So that's actually one of the key questions I ask. And regardless of how good the monitoring tool is, if the answer to that second question is no, we tend to walk away from that solution, right? Simply because we know that in order for us to get that big picture of how everything works, we really need to make sure, excuse me, we really need to make sure that it has the capability to integrate. So what we've done over here, I'll kind of briefly go through some of the monitoring capabilities over here, and then we'll kind of move on to it. I believe the next slide is and then we'll do a quick demo. So I'll quickly go through each one of these components over here, and then also our response automation. Excuse me. First of all, Zenoss is a traditional infrastructure monitor. It does the CPU, server up, down, and stuff like that. Zenoss actually has another capability that we found really interesting. Was Zenoss really kind of designed their product to be able to easily receive monitoring alerts from other tools that provide monitoring, right? So it's kind of a grand central station, if you will, for us with monitoring events. So we try to send all the outputs of all the other monitoring tools into Zenoss because we want to be able to go to Zenoss, kind of say, what are all the events are happening right now, right? And on top of that, Zenoss has actually got really good integration with ServiceNow for incident tickets. So we're able to really quickly set up, when a new alert gets discovered, we can really quickly set up that connection with ServiceNow to kind of say, hey, you know what, this event, we want a ticket for that, right? One of the things we also did with Zenoss, or just monitoring in general, with that ticketing capability, is that we spent a lot of time actually working with our operations team to ensure that we're only generating tickets for events that they deem actionable. So, for example, if there's a service down, we generate a ticket for that, obviously. But interestingly, for a CPU spike or a CPU hitting 80% or whatever that threshold may be, when it hits that threshold, we actually do not create a ticket for that. Because when we talk to our operations team, the feedback was like, look, when we get those tickets, we really don't do much with it, because more often than not, by the time we get to the server, the CPU spike is already gone. It's because, some job got run, or, and that kind of creates a CPU spike. It's normal. It's going to hit that 80% threshold once in a while. We're okay with that. So because of that, we actually weed out a lot of the stuff that our operations team doesn't actually take any action on. And between that and Zenoss' capability to do some deduplication for events. So for example, if a server is down, when Zenoss picks that up, you'll create the ticket, but in the next probe, say 5 minutes later, when it probes it again, it's still down, it doesn't create another ticket for it. What it actually does is it actually just marks the ticket with a count for the incremental count of 1, right? So you actually say, hey, you know what? I already created this ticket. The problem's still not solved. So now there's 2 probe sequences now that has picked up the fact that the server is down. And it will continue to do that incremental count until the problem is solved, right? And that ticket will remain open. Between the ability to be able to deduplicate like that, and also some of the work that we've done with the operations team to weed out stuff that they don't have plans to do action on, we were actually able to take the number of events and compare that to incident tickets and decrease that ratio by 99%. So only 1% of the events that Zenoss either generates itself or being fed by other tools, only 1% of those events actually becomes ticket. And that's tremendous, right? If you kind of think about the operations team, and most of the operations team are, for lack of a better word, a lot of times are short-staffed. So being able to kind of weed out a lot of the stuff that they don't need to take a look at is a great thing. So moving beyond Zenoss, though, we have OnCommand Unified Manager, NetApp tool, OnCommand Insight, NetApp tool, AppDynamics, which does our application performance management, and then Apika is a company that does business transactions. So think of this as the ability to measure the amount of time for a particular transaction to complete, on a website. So for example, let's say that I'm interested in the performance of the Amazon.com website. What I may be able to do is create a script that says, go ahead and log in, go search for an umbrella, right? Click on order for that umbrella, and then log out. And then so Apika you can script that with Apika. You'll do that process, and then you will capture the amount of time it took for each one of those steps. So give it an idea of how long it takes for a transaction to take place. Obviously, we'll call it synthetic transaction because everything is scripted. And then the Apika also has different, what we call POPs, where you can actually run this script from, so you can get an idea of, what the performance look like from different regions of the world. And then Prometheus, we leverage Prometheus to gather our metrics within OpenShift, which is a platform we run Kubernetes on. So Prometheus provides that metrics, some of the faults, some of the stats for that environment, and we send that to Splunk, which is our data analytics tool. And using Splunk, we're able to pick out, what is going on with our OpenShift environment, our containerized environment, and anything that's actionable. Once again, we send that to Zenoss, which creates that ticket. Okay, so if you kind of think about building this puzzle out now, right? We have the provisioning, and then the monitoring kicks in. One thing I will add, as far as integration goes, is that when, as I was mentioning before, when the resources are created, the CMDB automatically gets updated. There's integration between Zenoss and our ServiceNow CMDB in that Zenoss will actually look at the CMDB and see what just came live and became a productionized environment, and Zenoss will actually pick that up and start monitoring it automatically, so that there's not a manual effort for somebody to say create a ticket and say I need this thing not monitored. Everything is kind of integrated and automated. So now that we got the monitoring, well, what happens to some of the events? What if we have tickets where we see this as a common problem, we know exactly how to solve it. This is where the response automation with auto response capability comes in, right? So what we also have is a auto response capability where we take some of our most common incident tickets where we have the resolution for, and we create scripts for that. And what will happen in this case is when the ticket gets generated, ServiceNow will actually look into an internal mapping table and kind of say, hey, for this particular ticket, do I have some sort of automated solution for it? And if it does, it will actually trigger Ansible to go fire off whatever that script may be. It could be anything from, go reboot a server or to restart a process, or something sometimes a little more complicated than that. So basically, now what you see is, Zenoss creates a ticket. The ticket gets, looked up in a lookup table. If there's response automation associated with it, you'll actually trigger that response to act on the target. And once the issue is resolved, you'll update the ticket and say, hey, you know what? This problem happened. Response automation script was kicked off, and the problem is now resolved. We leave the ticket open at that point because, again, talking to our customers, i.e. the application and the infrastructure support team, they will prefer to actually take that final step of going in and manually verifying that the issue is actually resolved before they close out the ticket. We have the capability of actually closing out the ticket and complete that entire process, but that was their preference, so that's kind of what we're going with our operating model today. Okay, now notice that we call it response automation with auto response and not auto resolution. And there's actually a good reason for that. What we learned was that just because you don't solve the problem doesn't mean that there's no value in the response automation capability, right? And what I mean by that is sometimes when, especially a complex issue happens, if we can find out what engineers do as their first troubleshooting steps, which logs do they go to? Within the logs, what do they look at? When they get on the server, what commands do they run? Do they run, for example, a process list, a PS command? Do they, what are those steps that they initially go through, and what data do they gather, right? If we can script around that, then now what we can do is when that ticket gets created, it triggers the response automation script, and that response automation script will go run those commands for them, will go search the logs for them. And the output of that will get automatically entered into the ticket. So now when the engineer actually sees the ticket for the first time, some of the initial troubleshooting steps are already completed for them. They have the log, they have the output of what search that they would do within those logs. So they can quickly look at it and then decide whether there's further troubleshooting, or if hopefully they already know what the problem is and they can actually move on to the resolution themselves. So we find that there's tremendous value in that. There's obviously tremendous value in being able to actually resolve a problem, but in our use cases, we really do both. One of the more complex operations we have with response automation is actually what we did with our hardware. We actually automated the return authorization or the hardware return process using auto response, right? So when our servers pick up a faulty disk, for example, that will create a ticket, and the response automation will kick in, and it goes through all the steps that the vendor will want us to go through before we can actually create something to return the part. So for example, you actually run the vendor script that does the diagnostic. You'll collect that information, and then what it will do then is actually FTP all that core file, the outputs and whatnot, to the vendor site so that we can get that return authorization initiated. So it does a plethora of things, but ultimately the goal is to be able to shrink the amount of time that a human has to spend on a particular problem. So kind of putting all that together, right, if you kind of think about the story again, we got the automated provisioning on the right side, into our Cloud One infrastructure. As that process is going on, CMDB is updated, and once the CMDB is updated, our monitoring starts kicking in. Zenoss starts monitoring some of the stuff. Some of the other more exotic stuff, you wrote business synthetic transactions, application performance management, and all that stuff, we still set up manually today, but somewhere down the line, we're going to try to automate that as well. But in any case, the monitoring kicks in, and then if applicable, we create the response automation for that. So when the incident happens, we can hopefully resolve it automatically. Okay, so hopefully that helps paint that picture of, what we're trying to do as far as integrating the entire environment and really kind of take care of the environment from the automated provisioning, the lifecycle management as far as, keeping it up, keeping it healthy, and also ultimately the deprovisioning on the other side. So really the entire lifecycle and not just the beginning and the end. I'm going to kind of switch gear now and talk a little bit more about some of the monitoring stuff that we've done over here and the amount of integration that we have to do. One of the things that a lot of people are looking for, right, is that single pane of glass when they're monitoring an environment. And more often than not, it's kind of pieced together. Well, we actually spent a couple of years on this using different tools, but what we want to do is really create a dashboard where we can look at our application on a per application basis and be able to hopefully pinpoint really quickly what component is actually wrong with the application. One thing I will mention is, you know, as I've kind of worked on monitoring for the last several years, what I realized is that there has really been a paradigm shift in how we monitor. You know, even as early as maybe just 5-6 years ago, I think a lot of the folks really kind of, you know, when they talk about monitoring, they're really focusing on the infrastructure, right, the server, making sure the server is up. And the paradigm shift is that, you know, nowadays, I make the argument that it's a lot more important to actually make sure that the user experience is good and also the application is up. Because, you know, more often than not, the applications today are designed and architected in a way, hopefully, that if an underlying infrastructure piece was to become faulty, the application should be designed so that it will stay up, right, through redundancy, through horizontal scaling and whatnot. And also, if you kind of think about how things are working here now, a lot of the stuff over here is ephemeral. They're supposed to come and go. So to be able to use infrastructure monitoring as your focus may not always be the best idea. So one of the things we're really trying to do is, instead of looking from the bottom up, from the hardware upwards, up the application stack, we started looking at how do we go from the top down, really focus on the application first, and then if there's something wrong with the application, to have the capability to peel back the onion, if you will, to kind of see what is wrong at the core, right? So we still do monitoring for infrastructure, but now it's becoming the supporting data rather than the centerpiece of what we're monitoring.
Hey, Ed, it's Mary Jo. I have a question. So when I look at this diagram, it seems like there are a lot of tools. What's your opinion on that? Is this normal, or is this?
Sure.
I mean, how's that changed? Has it changed over time for us?
So that's a very good question. If you look at this box, is there a lot of boxes? Yes. Now, interestingly, though, when I talk to some of our NetApp customers, when we go through this slide, some of the feedback that I often get is actually, wow, you're able to cover 80% of the environment with a small set of tools. When I, often I talk to customers, like, we got like 30 tools, and 10 of which we know is out there, but we don't even know what they are, because sometimes, just like NetApp, IT, a lot of the IT department faces the challenges with their customers going off and doing things on their own, right? I kind of mentioned about how we started the cloud journey with, business units going out to get service on their own using their credit card. Well, people do the very same thing with in other IT enterprises with monitoring tools, because for whatever reason, they go off and buy their own monitoring tools. So really, we see a lot of situations with our customers where they have 15, 20, 30 tools, and a small subset of that number, they actually don't know what they are because their customers bought it and it's running under somebody's desk. So to answer your question, MJ, hopefully I'm answering your question. Does it look like a lot of boxes? Yes. Is this representative of a lot of IT enterprises? I will argue no, because I actually think this is actually a lot smaller set of tools than a lot of the IT enterprises I've talked to.
Okay, good information. Thanks.
Yep. We talked about the response automation a little bit already. In interest of time, I'm going to go ahead and skip this slide. But this is kind of describes the process in which we set up the response automation. Some of the other capabilities that we implemented, auto scaling is one of them. Again, as we provision those resources for the developers, if we started running out of resources, we have the capability to actually grow that automatically, both within the private cloud as well as AWS today. And as the jobs get turned down and the resources are no longer needed, we actually catch that, and then we also decrease the back-end compute resources so that we can save money. So growing it, we're never starving the application of resources, and being able to shrink it automatically, we're trying to conserve resources and obviously save money. Some of our strategy going forward. So, you guys saw, what we kind of implemented in the past, what we're working on today. Some of the stuff that we were looking forward to in the future. Obviously, trying to mature our Cloud One environment. And also from a monitoring standpoint, I talked briefly about one of the area already where we want to be able to automate the creation of those dashboards, automate the monitoring, some of the more exotic monitoring capabilities, to really be able to truly provide monitoring as a service where people can go to a service catalog and order something to be monitored and have that ultimately be created automatically in the back end, right? The other thing that we want to look at is the data that we've gathered for monitoring today is still reactive, right? Meaning we're looking at what's happening and say, oh, something is bad, something went down, somebody needs to do something about that. That is still our focus today. What we want to be able to do in the future is, kind of be able to catch the thing before that, right? So really look at patterns, trends of information that may indicate that something is about to happen rather than catching it as it's happening. So we're hoping to leverage, AI and ML capabilities to be able to catch something before it happens rather than catching it as it's happening. I kind of call it a paradigm shift from point-in-time monitoring to really doing the data analytics and intelligence. So really providing that intelligence that something's about to happen rather than just saying it's happening right now as we speak. That is the end of my presentation. Hopefully this was useful and give you guys a glimpse of how NetApp IT really is kind of looking at how we automate our DevOps environment, as well as how the importance of integration and putting everything together. So really have a what I kind of think of as a jigsaw puzzle that paints a complete picture using individual components. So again, thank you very much for listening, and I think we still got 6 minutes if anybody has any questions.
Hi Ed, it's Elias here. Thank you very much for presenting today. It's quite interesting, especially what you were saying about the monitoring tools and how you approach the vendors. And one of the questions I remember you asked them is if the monitoring tools can communicate between each other.
Yep.
That's quite interesting, actually. Yeah.
So, Elias, it's Mary Jo. Next month, we will have Mike Morris come in and talk about more detail around our Cloud One DevOps platform that has been put in place over the last 18 months, I guess, 12 to 18 months. I guess it went live almost 9 months ago. But he will come in and explain that, and then how the NetApp technologies come into play in that environment. So I think we're shooting for September 20th for that next webinar.
Okay, I'll get the invitations ready and send them out. So if people on the call, if you have any questions that you want to send me via email and all that, I'll be happy to forward them to Ed and to Mary Jo. Otherwise, I think that's it for now. Thank you very much, Ed. Yeah, very good presentation.
Thank you, guys.
All right. Thanks, everyone. Have a good day.
You too. Thank you. Bye-bye.